Okay, we're going to look at some shortcuts for the three things that we've been doing, those confidence intervals. There are programs built into the calculators to do this all very quickly, so don't hate me, but I'm just showing you both ways because I have no idea what's going to happen if you ever have to take this at the college level. Some of those people will use nothing but the tables like we've just done. Some will use technology. Some will do a little bit of both. So we're going to title this section 4.1, 4.2, and 4.3 Technology. Okay, I'm not going to make you write down all of the examples again. We're going to go back and redo a couple of examples from each section and see how quickly we can get the same answers we did by hand. So we'll go to our first one. It's going to be from section 6.1. And this was finding the confidence interval for large samples. So finding confidence interval for the population mean large sample. And I'm going to take you right back to example 1, where we had those, it was like the number of sentences in a magazine article, where we constructed the 90 and 95% confidence interval for the population mean. And we put all the data in. So our critical information was that the sample mean was 14.77. The sample standard deviation was 16.54. And we had a sample size of 30 magazines, and our confidence level is going to be 90%. So, and I'll refer back to the answer we got here when we get the calculator program going. Okay, so if we're doing confidence interval for the mean large sample, the program's name is called Z-interval. Interval because we're doing confidence interval, Z because it's large sample, and remember we use Z-scores and not T-scores. So you're going to find those programs under, you're going to go under Stat, right where our 1 bars is at, so press Stat. And then you're going to arrow over to Tests. And these are not tests, so we're not going to use Z-test. We're going to go down to here where it says Z-interval. There's our program name, so number 7. And we're going to be using statistics because we've got all of the data here that we need. If we were going to put everything into a list and run one of our stats, we'd use data. But let's just stick with stats all the time. So, so Z-interval, stats is what we want to use. And now watch how easy stuff is. Okay, they're asking for the population standard deviation, which we don't know, so we use S in place of it. And our S value was 16.54. The sample mean was 14.77. N was 30. Our confidence level does go in as a decimal, and we were doing 90%, so 0.90 or 0.9. Calculate. And look how quickly it gave us the answer that we had back when we did it the long way. 9.80 to 19.74, done. Don't hate me. So 9.80 to 19.74. Okay, our next example is going to come from 6.2. Where we were finding the confidence interval. For the population mean again, but this time with small samples. And remember, the difference here was that instead of using a Z, we were using a T. And we had that little flow chart to tell us whether we're using Z-scores or T-scores. Maybe I want to put a Z back up here. So if I go to section 2, and I pick an example from there, I'm going to pick this one where we selected 16 restaurants, where we measured the coffee temperature. The average temp was 162. Standard deviation was 10. Find the 95% confidence interval for the population mean. Assume the temps are normally distributed. Remember, if it's a small sample, they have to be normally distributed. And if it's an S value that they give us, the sample standard deviation, we use the t-score. If this happened to be population, we would still use a Z. But if it's a small sample with S, we're going to use this new program. So we're going to write down our key information. The average was 162 degree temperature for the coffee. Standard deviation was 10. Sample size was 16. And we were doing a 95% confidence interval here. And you can see our answers for the average temperature, what we expect the population to fall between. All right, so same thing, small sample. The program here is going to be called t-interval. We'll be using stats. So same thing, go under stat, over to tests, and not t-tests, these are intervals. We'll be using those in the next chapter. So go down until you find t-interval right below z-interval. And we're using stats, and again, it's just put in the information. Average is 162. S is 10. N is 16. And we're going for 95% as a decimal. And down to calculate. And there's our interval. I'll just show you how it compares to our answer we got by hand, 156.67 to 167.33, right on the money. But when it comes to doing this, they're all going to be mixed together today. Make sure you use your flowchart to decide whether a small sample should be using a Z or a T. I'm not going over all that again. And then our last section that we just finished up was proportions, and we'll pick one or two from there. Let's see. All right, and if you remember the steps, finding the point estimate, that doesn't have to be done this time. But you do have to make sure that your sample size is big enough to be normal with proportions, and that's that n times p hat. Well, I guess you do have to do this because you got to use it here for the check. Check that your sample size is big enough still, and then you move on to the program. So, the one we're going to do is this first one. So we had 1,470 people in our sample. So that's our sample size. And 98 chose Abe Lincoln. So 98 successes. And we were finding the 90% confidence interval. Okay, I'm not going to bother doing the check. It was big enough, but you're going to have to do that today. That step of checking to make sure the sample size is big enough. I'm going to go right into the interval and see if we can come up with the exact same answer we had. Okay, the program name here is called one prop zint. One sample, one proportion is all we're using. So they're all hidden under the same thing, under stat, over to tests, go down to not one prop z test, we want one prop z int. Right here, one prop z int. Okay, make it sure. Okay, they want to know X, N, and your confidence level. X is your number of successes. So for us, we had 98 successes. So your successes is your X number, which you already knew. So 98. Sample size was 1470. Confidence level, we want 90 as a decimal. And calculate. It goes through and calculates max error, adds and subtracts, and gives us our interval. And if you look, answer before by hand, 0.056, matches perfectly, 0.0707. So slightly off, but close enough for our purpose. 0.056, 0.077. Okay, and I do want to do one more of these, just to show you one little thing. The next one we did we were constructing a 92% confidence interval. So I'll write 92%. For the proportion of adults with high blood pressure, we surveyed 500. So sample size is 500. And it says 4% have high blood pressure. So our p hat is 4%. Okay, we want to do the same thing, assuming that it's normal, and we did the multiplying to make sure. We're going to run that program again, but do you know what to do? Stat, test, oops. Okay, X, remember, was number of successes. I didn't give you the number of successes, or they didn't give you the number of successes, they gave you the percent of successes. So how do you get from the percent of successes to how many successes? Well, all it is, I need 4% of 500. That's just a simple multiplication. So to figure out the X, 500 times 0.04. And you can actually do that right on this line, but then you just got to make sure it's a whole number. So 500 times 0.04, if you hit enter, it does. It is 20. If that had come out 20.05, you got to go back and round it normally. So make sure you round normally to a whole number. So not that round up like we did for minimum sample size, round normally. So okay, 500 was the sample size, and this time we did 92%. That was just to practice the z-score there, I'm pretty sure, by hand last time. And there it is. Should match exactly with what we had. 0.025, 0.025, 0.055, 0.055. Right on the money again. Okay, so you're going to have them all mixed together today, so it'll be a good practice, but all are going to be done with program. And it's all on a worksheet. So that ends our notes. So the homework will be a worksheet.